Howdy. In this video, we are going to continue doing the regression analysis. This time we are going to use Python scikit-learn package, and we are doing the predictive modeling and variable selection. I already started typing a couple of things that I have done in the previous video. These are basically importing pandas package and then loading the salaries file, adding dummy variables for the MBA, and then also reindexing the file to make sure that the employee IDs are the index and there is not a secondary index in the file. So when I print this file, this is the basically the appearance of the file. I have the salaries, age, relevant years of experience. I added another column. This is the number of reports, basically how many person are reporting to you or this employee. In this case, many of them has no employee reporting them, but this person number 3 has 8 people reporting to him or her. Then this person has an MBA and this person has an MBA. The others do not have it yet. Right now, first thing is because I'm gonna use this scikit-learn, I'm gonna basically import that one. sklearn, and I'm going to use model selection, right? Import train test splits, right? What I would like to do this time is basically in the previous stats models, I assume that my training data set and validation data sets are the same. This time I'm going to actually split them, build the model based on the training data set, and then validate on the validation data set. Right now that is there, I'm gonna create the X variables for training, variables for validation. It needs to be the training validation for X and Y's, by the way, and then Y for training, and then Y for validation, right? So I'm gonna create all those using this train test split function, right? And I want to do that one on the salaries. Again, for the xValid variables, I'm gonna drop the salary from the list. All right, salary, and I need to tell that this is based on the columns, right, as I did it in the earlier video. Then comma, for the Y variables, it is the salaries data frame, but just the salary field, right? And when I run this one, it should be okay, but I would like to add actually a few things. So at this point, basically, I just based on the, I think, 75-25 split, I divided the data set into training and validation data set, but I want to perhaps be more specific. So let me add few things to this initial parameter. So what I would like to do is define the size of the training data set, right? Train size, and that is, I want to be 60% of the data size. So in this case, I have about 35 data points. So 21, 22 of them probably is going to be in this training data set. And then the rest will be on the validation data set. I'm going to also define something called random state. And I'm going to put 5. Now, random state makes sure that these training and validation data sets are drawn randomly from the data by defining a random state. So all of us should have the same numbers. So basically, think about the random number generation as a function. So if we all start with the 5, then everything we do with this random number generator is going to be the same random numbers. So that way, if you do something and if I'm doing something, if we both starts with the random state, we will get the same results. Or if you started working on your laptop at school, but then transferred to your desktop, suddenly not all the results are changing because you just happen to have a different random number. Right. So this way, I'm basically making sure that every time I run, I'm gonna get the same results for my experiment. All right. So this is just a note that the feature is gonna change. And let me again just print the training data set. Right. So this is my training data set. Again, employee IDs are there, age, relevant years of experience, number of reports, and then MBA yes, no are there. So this is what I have. In the next step is that, as we discussed, we want to do the linear regression. So I need to call the linear regression function from our scikit learn, right? And call the linear model, right? And I'm gonna call this one the linear regression, right? And I can also say to reduce the work every time I don't want to write linear regression, so I'm gonna just say lm, and that way I can say linear regression function is gonna be the lm, and I can do lm fit. If you remember, fit function means basically use the linear regression to fit to a certain function, and I have trained the data, and then validation data. So this fitting is going to be done on the training data set. So I'm saying that x variables are xTrain and y variables are yTrain. By the way, if you guys remember, on the stats model, the order was y variables first and the x variables were second. So be careful about that one when you are working with these models, right? So let me run this. So and also I get an intercept which wasn't default in the stats model, right? So I have this one and I can check the intercept. Let's say intercept C. And what you need to be aware of is that whenever we have an underscore in regression or in Python in general, that means that the value is the estimate for the actual one. If you guys remember, we defined the regression model as y is equal to beta 0 plus beta 1 x1 beta 2 x2, but then we were basically doing the estimates saying that y cap is equal to b0 plus b1 x1 and so forth. So these are the estimates basically in essence, right? I could also check the coefficients. Again, I'm just using the tab sometimes to just make it faster for me. In this case, I have an array. What it means is that age has the coefficient of 983, relevant years of experience has minus 32 something, number of reports, how many people are reporting you, has this 930, and then MBA is 13,754. Now, in a long list of things, this might be difficult to see which one of them is actually matching these numbers. So we could actually merge them and create a list that is easy to read. All right, so I'm going to use that data frame function from the pandas, and I'm creating a list by merging. Zip is a merge function basically. xTrain column names, and then lm coefficients, right? So Let me run this one. Right, so now I can kind of easily read it. Age is 983, relevant years of experience, number of reports, and MBA, yes. Now this is 01. If I want to be more specific, I could actually even rename these columns, and let me actually do that. Columns are equal to the first column, I'm gonna call it attributes. Python actually calls it features, but doesn't matter. And then the second column, I'm gonna call it estimates. Right, so I'll rerun it again. So that is my basically result. Right now, in the stats model, there was a summary subfunction which allowed me to get the table, like the Excel one, and then read their R-square values, p-values, and so forth, and make an evaluation. Here in the Scikit, that's not that straightforward, so we need to actually call the metrics and then the operations on them, right? So let me continue on this idea. Say learn, right? Import metrics, right? Now I'm gonna calculate the R-square for training data and then the validation data, of course. And I'm gonna say metrics dot R-square score. That's basically what I'm saying. And I'm going to do this one based on the linear regression predictions, right? Based on the xTrain values, right? And then the other part is that the yTrain, right? So training data, x and y values, that's what I'm doing it. And I'm gonna do the validation R-square too. It's easy to just copy these guys here, actually, and then make some changes. This is xValidation. That's how I named it here. xValid, yTrain, and yValid, right? So, and this is y validation, right? And then I'm gonna just print out the results and see what is going on. So the first one is the training, comma, train R2, and then actually I didn't want to do that yet. Let me do this one here too, and validation, that is comma well R2. Right, now I can print it. All right, so on my training data set, the R-square value was 0.95.9, almost 96%. My validation data R-square is still very good, 93.3 or 93.4. So that gives me an idea that this model is working okay. Now, one thing we discussed in the class is this basically variable selection, right? We want to make the model as simple as possible by adding the few number of variables, and we discussed this forward selection, backward elimination, and so forth. So the next thing I'm gonna do is basically try to choose the best parameters, set of parameters, and for that, again from Scikit learn, I'm gonna say feature selection, right? That is extraction and selection. Extraction is backward elimination. And then I'm gonna import this and say select k best. So basically find k best parameters or variables. I'm gonna define the k as 1, 2, 3, 4. In this case, I have at most 4 variables, right? And then I'm gonna use the regression, right, model for this purpose, right? So let me execute that one. So I'm gonna define a function called select, and this select is going to use the select best k best, So let's say I want to choose two parameters, two independent variables for my model only, not, don't use the for, right? And I'm gonna score a function as the f regression, so it's gonna be scored based on that one, and that is right. So what I'm saying is that I'm gonna create a function, and this function is gonna select k best, and I'm saying k is 2, so choose the best two independent variable using the forward selection, right? One at a time, choose the best one, then add the second best after rerunning the model. And I'm saying that this selection needs to be based on the regression model, so r square. Right, so and then I need to, of course, again run this model, say that fit and fit using xTrain and yTrain, right? So the model is there. We chose k equal to 2 and using this f regression. Now you may be wondering which two I choose. Was it age and relevant years of experience or any other combination? For that, we are gonna use another function. It's called select get support. So basically I want to know right, select get support, and here's the right array. So it says the first one is selected, second one is not selected, third one is selected, fourth one is not selected. So if you will, this one is selected, not selected, selected, not selected. So that is the order. Of course, I can do the zipping again if I have like too many variables and I want to really know which one of them are listed. If you guys remember, list function is, I'm gonna first open the list and then zip it or merged with another list, and I want to do merge with the xTrain and select get support, right? Open parentheses, right? Let's see. So I'm basically matching those two, right? Age is true, selected. Relevant years of experience, false, is not selected. Number of reports is true, selected. MBA, yes, is not selected, right? Now I know those are the best two parameters if I want to choose two, but then how does the model look like with these two new parameter, age and or attribute, age and number of reports? So first I need to reduce the number of attributes to these two only, and then from there I'm gonna rebuild the model and then do the analysis, right? So initially my data has all these 4 fields, attributes, as a column of information. Now I decided that only age and number of reports should be used if I want to use k equal to 2. So the rest, these relevant years of experience and MBA, I need to drop them from the data, right? So I'm gonna define a new variable and say new xTrain, right? And this needs to be equal to select and transform basically the data from xTrain. So what it does is it goes back to the select function and transform the information from there and choose the columns that I need chosen as the best one, right? So that is there. Now I have a new one and I can again fit my function. This is new xTrain, comma yTrain. Nothing has changed about the y because it's still the same y. It's just I dropped some of the columns from the model. Right. Similar to earlier line. So we got some information. I can do lm intercept and so forth. but I want to know actually what are the R square at this point. So for the training data set and validation data set. So let me go do that one again. And for that, perhaps I'll just copy these and then make the modification. So train R2 metrics is this one, predict, right? I use the xTrain. This time is the new xTrain, so I'm gonna add that one, right? Now in the validation data, so xValid right now has those 4 columns that, because I did remove for the training data, but I did not remove for the validation data yet. So I'm gonna go do the same thing. I can just directly go basically use the transformation to get the columns I need. All right, select, transform, right, and open parentheses, x validation, right? Again, y validation does not change. I could also, like this here, new xTrain, select, transform, xTrain. I could add a line saying that new yTrain validation, new x validation, and then use the same function to get it, right? That way I would have done a simplification, and here I would just say new x validation rather than using this function here, right? So there is many way of doing this thing, right? So let's do the look at the result. Now in the training data set, R square is 0.8, but on the validation data set, the R square is 0.6. That's a little bit worse than what I would expected. Right? Now, of course, this is just one of many possibilities. I could also check the one, only one basically variable. 2, I just checked it. 3 and the 4 also was there. So I could just, like, let's say I have 20 of them. I could just check 1, 2, 3, 4, 5, up to 20 of them and see which one of them has the best R square value, right? So I'm gonna define a K range, but I don't need to do this one if I don't want. It just helps me to organize the things better. So let's say I will define a K range that is basically the K in this best fit. If you guys remember, select K equal to 2. So I'm gonna say I could select 1, 2, 3, 4, and each one of them will give me the best solution. So that is what I want to do. And I'm gonna create a list, and I'm gonna put the range. In the range, I'm gonna start from 1 and 1, 2, 3, 4. In Python, if you want to add the 4, your upper bound is 5. So it starts with the lower bound 1, but it ends at 5 minus 1, 4, right? So let me actually check this and show you what I mean with that. All right, so I added 5, but it's not included. It's up to 4. So in the K best, I'm gonna check 1, 2, 3, 4 basically. Right. Now I just did it for 2 and it took some time. And again, if I have let's say too many independent variables, I don't want to do this one at a time, but rather automate it, right? So let me show you how to automate this process. First, I'm gonna define another basically array, and I'm gonna call it score. So I'm gonna keep the scores here. At this point, it is empty, right? And I'm gonna iterate from 1 to the number of independent variables I have. Here it is 4, and I defined already that as a list as well. So I'm gonna say for I in K range. So, and remember, K range is 1, 2, 3, 4. So it's gonna try I1, I2, I3, and I4, right? And then I'm gonna say select. This is basically what we have done earlier. Actually, I could just copy this line here. All right. Select k equal to not 2, but the I, and I is going to change, remember, right? And then I will do select with xTrain, yTrain. And then I did basically use this or created this new xTrain. That was the transformation, reduce the number of columns or the attributes. And then I fit the model to this one, right? And then finally, I basically calculated this metric here and then add it to my list, right? At this point, I mean, I could calculate the train data R2 and validation R2, but what I am interested is how this model is going to perform in real life. In real life means I don't really know, or I haven't trained this model based on this new data that I'm going to introduce. So I'm going to just use the validation part of it, right? So let me copy this one, but again, I could just print out as many information as well. And I'm gonna say score, k-score, the one at the end, and I'm gonna append to that one whatever I found right now, right? Metrics R square, lm.predict, select, transform, x validation, y validation, and that is basically it. Once I'm done with all this, I can print the k score underscore score basically, and that would be my result. Now I don't need to do it one at a time, and this code will just check all of them, right? So what am I seeing here? When I is 1, I get the R square on the validation data as 0.35. When I is 2, I get the 60%, 60.7. When I is 3, I get 58.9. And when I is 4, that is 93. Like all this, basically this indicates to me that there is a significant change in the R square value whenever I reduce the number of variables, and perhaps I should keep the 4 variable in this model, right? Now, again, this is like looking at the numbers. I could also check the a figure to help me visualize it better. So I'm gonna say plot. Actually, let me, before doing that, I need to import the matplot. We discussed this one the other day as well, and pyplot, right? And I'm gonna call it as PLT, right? Now I can call the figures, right? And then plot. I'm gonna plot the figure, and I want to do k-scores, right? And I'm gonna label the x and y coordinates. X label is let's say number of variables, right? And then y axis is y label is validation R square, right? And then finally show this figure to me, right? Hopefully this is gonna work. I made it somewhere plot, right? So here's the correction. So this is basically shows that when I have went up from, it starts from 0, it's a numbering system. It was about 35, then when I had 2, it was 1, 60 something, and then dropped down to 59, and then went up to almost 94, right? I could actually make this figure a little bit bigger and say figure size, and let's say 10 and 8. Right, so it is a little bit better. And again, if I have more variables, I can check it much better. Now, again, this tells me that I should basically keep 4 variables, and let me go back and do a couple of changes here. Now, if you guys remember, I said there is a random state. Basically, it allows me to get the same results again and again. It's kind of a seed for the random number generator. So let me try some different numbers, right? Let's say let's see what happens if I make it 7. Right, so I just changed random seed to, or random state to 7, nothing else. I'm gonna come and run this one, right? So suddenly, when I have 1 variable, it is better than having 2 and 3 variables. Of course, 4 is still better in the 4 overall, right? But if you guys look into this one, initially I had like basically when I have 1 variable, the r square was less than 0.4. It was around 61% and 59% and then 93%. But this time with a different random number, I just got a totally different result. All right, I could change it to, let's say, another number. Let's make it 19. I'm just trying another. So I'm just changing this line and then coming back and rerunning these results here, right? Oh, this time all of them are over 90%, right? So that basically, if I look at these and I say, okay, I'm just gonna keep it simple, I could even go with a single variable, and that gives me 90% r square value. Now, what we are seeing here is a commonly known problem. As the random states changes, we will end up with different numbers. So to avoid this issue, we do something called cross validation, right? And I'm gonna talk about the cross validation in another video in the future.